Next is isomer shift. What is meant by isomer shift in Mossbauer experiment? Now, in a Mossbauer experiment, if the environment of the emitting and absorbing nuclei are different, we know that in a Mossbauer experiment we have some nucleus that is emitting gamma rays and some nucleus that is absorbing it. So, suppose the environment of emitting and absorbing nuclei are different, then the energy of the nuclear transition h nu differ by a small amount. That is, there is a small shift in the energy of nuclear transition that is observed in Mossbauer spectrum. That is called isomer shift. The main reason for isomer shift is the environment of emitting and absorbing nuclei are different. So, if we consider isomer shift, there is a cause and there is a result. What is the exact cause of isomer shift? This is because nucleus is not a point charge and has a finite charge distribution. We cannot assume nucleus as a point charge. The small shift in the spectrum is due to the fact that nucleus has some finite charge distribution and this affects the position of the spectrum. So, there is a small shift that is called isomer shift. Now, what is the result of that isomer shift? The result is that there is a shift in the resonance line from the 0 position. Due to isomer shift, there is a shift of the resonance line from the 0 position. It is also called the chemical shift in Mossbauer spectroscopy. Since it is a shift, we can express it. How can you express the isomer shift? There is a mathematical relation for isomer shift. This is given by 2 pi by 5 z square Re square minus Rg square into psi of a whole square minus psi of s whole square at ground state, where Re represents the radius of the nucleus in the excited state and Rg represents the radius of the nucleus in the ground state. The subscript A and S refers to the absorber and the source, that is one corresponding to the nucleus that is emitting radiation and the one corresponding to the nucleus that is absorbing radiation. Simply you can say that isomer shift is due to the fact that if the environment of emitting and absorbing nuclei are different, then there is a shift in the spectrum, that is called isomer shift. The cause is nucleus has a finite charge distribution and the result is that there is a shift in the resonance line from 0 position. Also, we can express the isomer shift like this.